Okay, let's take a look at explore number 2 of erosion and deposition. We're going to go ahead and take our essential question from the text. What are the specific agents of erosion? What are the things that cause erosion, and what factors control the depositing, the deposition of that sediment? Okay, so go ahead and draw your Cornell note lines. Go ahead and date it. Put your reference, Discovery Education, Living Earth text, Unit 2, Chapter or Concept 6, and we're looking at Explore number 2. And go ahead and hit the pause button. Tell me what you know. Tell me what you think. Okay, well, hopefully you did that. So we're going to go ahead and take the first um, title here, subtitle, I guess, Methods of Sediment Transport. So we're going to talk about how when you have erosion, how that sediment, remember sediment or detritus, detritus is the broken down material. We call it sediment when it is being transported. So what are some of the ways that this can be moved or transported? Okay. And we're going to just take the text and break it into usable notes. Letter A. We're going to start with the most powerful, the most common erosional agent out there, water. Okay. When we're talking about water, you might think about rivers, for example. You could think about oceans and waves and things like that. But we'll kind of focus on the river here. There's a term called bed load. Okay, and bed load, as you can see here, it describes the sediment that's carried in a river. Especially after a winter rain, when you've had a lot of storms, there's a lot of water that's flowing in the river. So the rivers might be moving a little faster than normal, and they're carrying a lot of dirt. There's a lot of bed load in the river, right? Um, as you can see, small a here, the speed of the water and the size of the sediment, right? What we call sediment grains, affects how sediment is eroded. That should make sense. If you have really, really big rocks, the river may not be able to carry or move those rocks very easily unless it's very, very fast moving water. So here you can see speed is going to really affect the size of the material that can be transported. Okay. And also the size of your sediment. You may have slow moving water, but maybe the dirt is just very fine, very small particles of dirt. Then that can be transported very easily, even if the water speed is slow. Okay. Number 2, rivers carry bed load by 3 processes. You can see I've got those letter A, B, and C. We've written those in blue. You have traction, you have saltation, and you have suspension. Traction. This occurs when water does not have enough energy to pick up the sediment grains. Um, okay, so the water might be moving a little too slow. Maybe the sediment is really big, and even though the water is moving okay speed, it's not fast enough to actually effectively move it. So sometimes those objects just might be dragged across the river bottom, very short distances. The second process is called saltation. That in Spanish, of course, saltar means to jump. So this occurs when water has only enough energy to pick up the sediment grains and transport them over short distances. As the water slows down, the sediment is going to sink to the riverbed. It's going to be deposited. And then it, maybe a little quick current of water catches it and it picks it up again, only to drop it down again. And so the sediment has the appearance of hopping or skipping along the riverbed, short distances. Okay. The third process is called suspension. Suspension means really to be carried, right? This occurs when the water speed is fast enough to pick up the sediment grains and transport them over long distances. So when you have very fine sand, or you have silt, or you have clay, very small particles, that just looks like the water is just brown, and you know that that's probably going to carry that for many miles. Okay, so that would be suspended or suspension. Are there other agents besides water that can do erosion? Well, of course there are. Many of you guys have suggested in our discussions that wind is capable of eroding and depositing. Remember, eroding means to carry or transport, and deposition means to set it down somewhere. The same terms are used for the most part with wind. You can have things be suspended. You can have things that just kind of skip along, right? If you got some heavier material, maybe the wind is able to kind of blow it a short distance, and then it doesn't have enough energy to keep blowing it, so then it gets deposited, and then maybe another strong gust of wind carries it a little bit further. So you can have saltation. And then you have surface creep, which would be very similar to what was the term we had for water? Traction, right? So you can have surface creep where something just kind of gets dragged little by little. Okay, maybe a bigger object that really the wind doesn't have enough speed to really pick that up. Okay. Number two, except for unusual conditions such as hurricanes. Remember, hurricanes can have speeds over 75 miles an hour into the 100 mile plus miles per hour, right? Winds, unless you're talking about those unusual conditions, hurricanes, tornadoes, for the most part, wind is not usually strong enough to carry large sediment grain. Okay, and that makes sense, especially out here on the West Coast in California. We don't really experience a whole lot in the way of hurricanes and tornadoes. So the wind that we usually see is not strong enough to pick up big material. Okay. Number three, where large sediment supplies accumulate with little vegetative cover, the wind can strip the land bare. This often happens, especially with commercial agriculture, farming, where we go in. You've seen it in the Salinas Valley, um, around Greenfield and King City. There's no crops planted. The tractors have plowed all the fields, and there's no roots to hold the dirt down, right? It's just loose dirt. And you've all seen on windy days how the wind just picks up all that dirt and moves it away, and the air just looks really um, hazy, right? Like there's a lot of dirt in the air. And that's what they're referring to here, that land can be stripped bare if you have large deposits of sediment with no vegetative cover, no plants holding it down with their roots. Okay. Well, let's not stop there. You also have gravity, which can be an agent of erosion. This especially is seen when you have sediment that's on a steep slope, what we would call an incline. So I've drawn this little picture of a mountain here, and I've drawn in brown some sediment that is on the mountainside. Because it's on an angle, an incline, gravity tends to pull this stuff down. And depending on how steep the incline is, you may have many rock slides or rock falls, right? Sometimes you'll see they put nets on the sides of mountains on the highway so that the rocks don't hit your car. You can have landslides. We see that on Highway 1 near Big Sur, where the water makes the ground very wet and gravity is pulling that dirt and it causes it to slide down. And you can also have mud flows, where you just have large mass movement of mud, right? And gravity in all these examples is acting on this. It doesn't talk about this in the book, but avalanches would be another example of gravity affecting a collection of material, large mass, ice in that case, right? Well, that brings us to our last agent of erosion that we're going to talk about, which is ice. Okay, you might think about the North and South poles. We have glaciers that are on the land. We have ice sheets that cover the ocean. Um, in both of those cases, and especially when we've had ice ages, these ice sheets and glaciers, they can grow quite large, covering large swaths, large regions of land and ocean. Now remember, ice freezes, and whatever it's touching underneath, in this case, if it's on land, it's going to be covering dirt and rocks. Well, that stuff can get frozen to the underside of the ice. As the ice moves, it moves the boulders as well. It moves the dirt as well. If you have sea ice and it had maybe you had some glaciation where some land ice made its way onto the sea ice, then you may get some of that debris on the sea ice as it melts and breaks into what we call icebergs. Those icebergs can flow along the ocean, along the major currents. As the water warms up, the icebergs melt, and whatever they're carrying with them, whatever sediment they're carrying with them, is going to then be deposited. Maybe it'll be deposited on land, maybe it'll be deposited on the ocean floor. Okay, so these are some examples of erosional agents. And your text has kind of gone through that. Remember, this is just stuff we're taking directly from the text, and you have some good videos. So make sure you watch those videos as well, just so you can gain a deeper appreciation for this. Okay, so now there you go. Got some good images on moraines. We talked about moraines over here. So take a look at these pictures and just get comfortable with these concepts. Roman numeral 2, sediment size and deposition. Okay, so if we start here with letter A, sediments are classified by the grain size. Okay, that's the term you're going to hear for the rest of this lecture presentation. Um, Grain size just basically says how big the rock or detritus is, right? It can be very large, it can be very small. There's 7 major categories, and there's a scale that, let's go ahead and take a look at the scale right there in your book. This is called the Wentworth classification system. Okay, so number 1, you can see Wentworth scale. It is centered at 2 millimeters, marking the boundary between sand and gravel. So here's the top, uppermost part of the scale. Here's the lowermost part of the scale. If we go somewhere around the middle, it says that it is centered at the 2 millimeter mark. See the number 2 there? And the number 2 there. So you could draw a little line if you wanted to. And we did that over here in your notes. We drew a line between gravel and sand just to show that this scale is centered at the 2 millimeter mark. Otherwise, from that, it's pretty straightforward. You can have different types of sand. You can have very coarse sand that is 1 to 2 millimeters in size. You can have coarse sand that is a little smaller, 0.5 to 1 millimeters. You can have medium sand, which is 0.25 to zero point 0.5 millimeters. You can have very fine sand, which is 0.125 to 0.025 millimeters. And we can still go smaller. We can have silt, which is 1 to 56 of a millimeter to 0.125 millimeters. And then the very smallest type of detritus or sediment is clay, which is less than 1 to 56 of a millimeter. Well, what about bigger material? Well, yeah, you do have bigger material. You have things like gravel, 2 to 4 millimeters in size. You have pebbles, which are 4 to 64 millimeters in size. Cobble, which is 64 to 256 millimeters in size. And anything bigger than 256 millimeters is called a boulder. Okay, so again, Roman numeral 1, we were talking about the agents, things that can actually move your sediment. And in Roman numeral 2, now we're actually talking about the sediment itself. How do we classify this stuff? Okay. The last thing that you're going to cover in your text here, and remember, my notes are not a substitute for reading the text. You really should be reading the text, okay? You have a nice diagram. I went and took time to redraw this in the notes because I want you to write this in your notes as well. This is called the Holstrom's diagram. It is a graph. You can see it is a graph. It's got a y-axis and an x-axis, and it relates the speed required of a stream. So here we go, the velocity, right? That's the change in speed. To erode and deposit different sized sediment. And on the bottom, we have different size sediments. Maybe if you take a moment to look at this scale, you'll notice something interesting about the numbering. On the y-axis, it goes from 1 to 10 to 100 to 1000. That's a logarithmic scale. It's increasing by factors of 10. 1 times 10 is 10, 10 times 10 is 100, 100 times 10 is 1000. You'll notice also that on the x-axis, the sediment size is also logarithmic, starting with 0.01 millimeters to 0.1 to 1 to 10 to 100, a factor of 10. 0.01 times 10 is 0.1, 0.1 times 10 is 1, 1 times 10 is 10, 10 times 10 is 100. So we would say that this, as you can see here in red, I said that this is a double logarithmic scale, meaning that you have two scales that are logarithmic, double, okay? So now take a look here. You'll see in blue you have things like initial erosion, something that can be lifted up and moved. You have continued transport, where something that's in motion can continue to be moved. And then you have deposition, where something drops to the river bottom. Well, let's take a look at something that is 0.1 millimeters in size. Let's imagine that you have a piece of sediment that's 0.1 millimeters in size. Well, if you take this dotted line, and my drawing isn't exactly perfect, but I think you get the idea. If your water speed is over 100 centimeters per second, the river is going to be able to pick that piece of sediment and move it. If you get a little slower than that, let's say that you get to maybe 70 centimeters per second, maybe 50 centimeters per second, the river would not be able to lift up and begin moving that sand. But if it is already moving, it can continue to be transported. Okay. If the river starts to slow down below 1 centimeter per second, now you'll notice we start to drop into this purple zone. Now that sediment cannot even be transported. Definitely can't start the movement, definitely can't continue the movement. The river is going too slow. And so below, let's say 0.5 centimeter per second, the sediment is going to drop to the river bottom. Okay, and that's how you use this Holstrom diagram. It kind of helps us quantify um, these ideas of river speed and its relation to sediment size. Wow, well, that was a lot. Well, what I want you to do now is I want you to write yourself a summary paragraph. Okay, try to do as much of this from recall, from what you can recall, all right? Because we're in the business of making this stick in our brains. And we'll talk to you soon. Take care.